Hello, hello. We are back talking about Chapter 8, Lesson 5, Direct Variation, Example number 3. And today we're looking at a money application. We're looking at this problem. It says Mrs. Perez has $4,000 in a CD and $4,000 in a money market account. The amount of interest she has earned since the beginning of the year is organized into the following table. Determine whether there is a direct variation between either of the data sets of the data sets and time. If so, find the equation of the direct variation. All right, so this problem is talking about a few things. What I see is that it is talking about what is called a CD and also money market accounts. Okay? So I don't know if you know what a CD or a money market account is, but I thought maybe we would go ahead and go over what that was. So a CD is also known as a certificate of deposit. Now, if you go to a bank, okay, usually they have what's known as something that's called savings accounts and checking accounts. You know, the point of a savings account is to, save money, and sometimes you'll generate interest on how much you're saving. And a checking account is kind of more when you're doing a lot of transactions, like you're going to the store and use your debit card. A lot of times that debit card goes out of your checking account when you pay for something. So there's a lot more transactions, and when I say transactions, that means you buy a lot of things more out of a checking account than you would usually in a savings account. But a CD is a special type of savings account, and what that means is a CD usually is for a significant, usually $100 or more, and they usually have a higher interest rate than a savings account. Okay, now that's awesome. There's a higher savings account. So if I have a bunch of, let's say I have $5,000 and I want to go ahead and put that in a CD, well, that's way better having a higher interest rate. I can earn more money on my money than if I just go into a regular savings account. The interest you're going to be gaining on that amount isn't going to be as much. So that's really, really cool. You get a higher interest rate than a savings account. You can earn more money for your money, but it kind of comes at a cost. And what that means is that if you go ahead and invest your money into a savings account, into a certificate of deposit or a CD, you have to do it for a particular amount of time, and that is called a term, which is called an amount of time. Okay, so what you get is you get a higher interest rate, but what that means is that your money has to stay in the bank for a certain amount of time, whether that's a month, 3 months, 6 months, 5 years, 20 years. If you get one of these, you have to leave your money in the account for that whatever that specified amount of time is, and you get to choose that amount of time. And the interest rates, for the bigger amount of time, you're probably going to have a higher interest rate than a small amount of time. So now what happens? Let's say I put $5,000 into certificate of deposit for a year, and let's imagine I own a house or something, and then let's say my heating system breaks, and I need to buy a new heater, and I need that $5,000. Well, if you go ahead and get that $5,000 out of the certificate of deposit, you can do that, but what happens is you have to pay a penalty, okay? And that penalty means that you're not gonna, if you put in $5,000, you're definitely not getting $5,000 back. You're going to get a fraction of the $5,000. But if you really need a heating system and you need your money, then it's kind of worth it to get it out if that's something essential that you really, really need. That's kind of what a certificate of deposit is. You get a higher interest rate than a savings account, and you have to do it for a specific amount of time, or there is a penalty you have to pay. And the penalties usually are not good. It's not like it's a $15 penalty. It's like a big penalty you have to pay. Okay, so in comparison with the certificate of deposit, this question is also talking about it's a money market account. And I had to research this because I didn't even really know what a money market account was, but it is actually the same type of thing. It's better than a savings account. So you can get a higher interest rate on it. So it has a higher interest rate. So that's the same as the CD, higher interest rate. Okay. Then a savings account. And with this one, you can take money out of it, but you only have a certain amount of transactions per month. So what I was reading is it said something like you can only do 6 withdrawals. That means when you take money out, 6 withdrawals out of your account a month. So if you did more than that, so more, you would get a penalty. Or what they said is if some banks, they have a certain amount of money, like let's say you have to have at least $1,000 in your money market account at all times. Well, if for some reason your $1,000 drops below and now it's $900, you could get a penalty for that as well. So this was more withdrawals. You get a penalty if it's more than 6, and also if your balance drops below a specific amount, you would get a penalty. Okay? So these are 2 things that are definitely better than a savings account in the fact of being able to achieve interest for your money, but they come with a catch. The CD, you have to have that money invested for a specific amount of time, and if you try to take it out before that time, you get a penalty. And money market, this might be better. So like if I had a bunch of money in there, and I'm going back to my house example where let's say I had $5,000 in there and my heating broke, well, as long as that was the only withdrawal, or was one of the only 6 withdrawals, I could take money out of my account to fix that heater as long as it didn't drop below whatever balance the bank said has to be. I have to keep my balance above the specific amount. So both things, when you get older, if you ever get one of these things, you want to make sure that you read the fine print to know all the details with each bank, because they're going to be different from bank to bank or credit union to credit union. So now that you guys kind of hopefully understand that, let's go back to this. It says Mrs. Perez has $4,000 in a CD, okay, and $4,000 in a money market account. The amount of interest, so those are 2 different things. And if you see on this table, this right here, this is the data. So she has 2 different accounts from the interest on the CD. Okay? So for the 0 months, she didn't get any interest. For the first month, she got $17 interest. From the second month, she got $34 interest. From the third month, she got $51 interest. And from the fourth month, she had $68 in interest. Okay, so that's the interest from the CD. So the $4,000 she invested in a CD. And then $4,000 in a money market account. So this data over here is the interest earned from the money market account. So when there was no time, she did not get any interest. But when there was 1 month, she got $19, which was better than the CD. After that, the second month, she got $37 interest. The third month, she got $55 interest. And the fourth month, she ended up getting $73 interest. So it really looks like out of for this example, she was actually earning more interest from the money market account when we just look at the data. But notice that there's two different tables here. When we look at this here, we are going to have the time. That is going to be our X, okay? And the interest from the CD, that's going to be our Y. And the interest in the money market is also going to be our Y. But what we're going to have to do is we're going to have to differentiate between these two because we can't have Y and Y. So what we're going to do is we're going to have to call one of those Y1 subscript 1. And the other one's going to have to be Y subscript 2. Okay? And I'm just having a difficult time here with my gel pens getting them to work. So this is Y1, and this is going to be Y2. Okay? Perfect. Okay, so let's get back to the problem. Okay, it says the amount of interest she has earned since the beginning of the year is organized into the following table. So here is the X with this Y1, and then here's the X with this Y2. So it's actually two different tables. This is the first table, and this is the second table, but they've kind of just conveniently put it all into one table. So we just need to understand how to read this table. This is the X and the Y1 value, and this is the X and the Y2 value of two separate things. So the amount of interest she has earned since the beginning of the year is organized into the following table. So what we need to do is we need to determine whether there is a direct variation between either of the data sets in time. And if so, we need to find the equation. Okay? So first off, we need to figure out if there's a direct variation. If there is, then we need to find the equation of the direct variation. Awesome. Let's get started. So remember, whenever we're figuring out the direct variation, we are looking at the value of K, which is the constant, and that is Y over X. So in this instance, we're going to start looking at Y1, where Y1 is the interest that represents the interest from a CD over the X, which is represented the time. Okay, so if we're just looking at symbolically, we're going Y1 over X, and we need to have the constant K every single time. If we're actually looking at the meaning behind what that means that the interest from a CD over time is constant. Okay, and if it's constant every single time, then that is a direct variation. So let's go ahead and look at this first one first, okay? So we're just going to look at all of these relationships from the interest from the CD from month to month and see if they have the same constant of variation. If so, it's a direct variation, and then we need to write an equation. All right, so the first one here, we have 17. So we're going to go 17 over 1 month. Okay, that's 17. Awesome. Okay, let's look at the next one. 34 over 2. Well, 34 over 2 is, what is that? 2 goes into both. 2 goes in there 17 times. 2 goes in there 1. It's 17 over 1. Perfect. Same thing. Awesome. Okay, let's look at the next one. It's 51 over, so these two are the same. 51 over 3. Okay. 51 over 3. Does 3 go into 51? I don't know. 5 plus 1 is 6. 6 is divisible by 3, so that means 51 is divisible by 3. How many times does 3 go in there? Let's see. 3 goes into 5 one time. And how many are left over? 2, and then drop the 1 to be 21. 3 goes into 21 7 times, so the answer is 17. 17 over 1, or just 17. Okay, perfect. We just need this last one to be the same. So far, this is definitely looking like a direct variation. Let's do this last one, 68 divided by 4. 68 divided by 4. equals, okay. Does 4 go into